Well, welcome everyone to this month's CDF. Today we've got Rajat Shinde, who's going to present on the GeoCroissant and how it will help data repositories and system of getting geodata set up for AI ingestion, I guess. Not too familiar myself with it, so it'll be great to have you and appreciate you coming and giving this presentation. If you want to share your screen and get started, that'll be great.
Great. Thank you, Nick. Thank you for the kind introduction. I have requested uh, to be a host for sharing the meeting.
Okay, I think you can now.
Yeah, I can now. Thank you. Can you please confirm if the screen is visible?
I see it.
Okay, great. Hello, everyone. I am Rajat this side. I come from NASA ODSI, which stands for Office of Data Science and Informatics. I am based out of Huntsville in Alabama. So it's still a little bit hot over here, and we are transitioning into cooler weather day by day. Today, I am going to talk about GeoCroissant, which is a metadata framework for geospatial, machine learning ready or AI ready datasets. I see some familiar faces in the crowd. Siri is also there. Hi, Siri. We had a really good discussion during the IGAS when uh, we met in Brisbane this year. So yeah, I think I have 15-20 minutes for the presentation, and then I'll quickly go through the specification as well so that we can discuss what we are proposing and how we all can come under the same umbrella for this. Again, thank you for taking out time to listen to me, and I'm happy to answer any questions going forward. So, starting with GeoCroissant, GeoCroissant is an extension which comes out of an existing standard named as Croissant. And Croissant standard was initiated by MLCommons, which is a collaborative consortium where people from different organizations come into the picture and they work on AI ML ecosystem related problems. So, Croissant came into existence because the AI ML community felt that the dataset metadata was lacking in terms of representation. And that's how the picture began. Uh, they discussed that JSON LD or JSON linked data would be a really good format to have metadata representation. And then their first release, we released first version of Croissant last year as a part of a NeurIPS paper, as well as the standard, which is available online. I'll send all the links later. But to have a brief introduction about Croissant, so it's a standardized metadata format. It was originally released with a vision along with its other extension for responsible AI to represent dataset metadata using JSON LD format. And that could be used in all the machine learning frameworks. So if you have to run your code in workflow, you can use with PyTorch or TensorFlow. And then on the dataset provider side, Hugging Face and Kaggle provided their integration so that if you are hosting a dataset on Hugging Face, you can directly create a Croissant file format and then you can use it and share it as a file to use along with other frameworks. So it was developed with four specific users in mind: creators and maintainers of ML datasets, ML researchers and practitioners, and then responsible AI researchers and practitioners. Because a lot of the participants in the dataset development for Croissant field comes from different domain. So we represent geospatial domain. There are people who are coming from health domain and others as well. So it was important to address the need for responsible AI development in the metadata representation as well. And then, of course, the policymakers who will be using these croissant datasets for their own applications. Because the way croissant is being developed, it is human readable as well as machine readable in its representation. So that's what makes it somewhat special in terms of its design. Uh, in terms of features, it was majorly targeted towards four features, which is downloading, searching, creation of croissant datasets, as well as loading. And all of these features cover different aspects of the end-to-end machine learning workflow or AI/ML workflow, which we typically use. So, for example, any user who wants to work on a AI/ML problem, they need data sets to work on. So they'll go to openly available data repositories such as Hugging Face or Kaggle, which are directed towards AI/ML datasets, and then including OpenML and Dataverse as well. And then a question comes up. If I don't know what datasets I want to work on, then I'll be using the search facility. And then comes the use of tools like Google Dataset Search or Kaggle Dataset Search. Third option is if I'm coming from the dataset provider role, and if I want to create a Croissant dataset, how can I use the Croissant tools, which includes a Python package, MLCroissant Python package, and also an editor to create these datasets to be used across different fields. So that is also possible. And then finally, if I have all the things, I have the Croissant dataset, and I want to run my algorithms, be it any machine learning algorithm or foundation models or large language models, I just need that Croissant dataset, and I can load it using the TensorFlow's Croissant builder or PyTorch support and run it end to end. So with this also complies with a lot of development which has been happening in geospatial domain. I'll come to that in a second. This is a high-level overview. I have discussed majority of it, but as I was discussing, like from data users, data creators, and data repositories perspective, Croissant integrates all of these, which are different, we can say, foundations of the AI/ML ecosystem. But then when this was released, we found out that there is a major gap in terms of how data is being used across domains and across different communities. And this is something which we pitched GeoCroissant for, because a lot of these metadata representation in Earth observation domain has been advanced to a greater level as compared to what Croissant offers. And we have been doing it in our geospatial ecosystem, be it the geosemantic side where we are using Sparkle or GeoSparkle based querying based on geospatial knowledge graph, or be it on the data repository side where we are already using STAC or OGC's training data markup language as standard. But the geospatial community was not aware of how these AI/ML tools can be used. And to accelerate the AI/ML workflows, we needed something which kind of sits in between the AI/ML ecosystem problems and GeoAI problems. So since the time of inception, we were very clear that we do not want to reinvent any of the metadata standard, which are already there in geospatial domain, but we will go ahead in developing and connecting these things so that the AI/ML ecosystem can come closer towards GeoAI issues, and GeoAI community can work along the AI/ML datasets very easily. Now, a question might come, what exactly is difference in AI/ML datasets and GeoAI datasets? So typically, these things which we are seeing in Hugging Face data repositories or Kaggle data repositories, the datasets are majorly tabular or structured in nature. But when we come to geo datasets, these datasets are big and huge in terms of size, in variety and all those things. Plus, there are vector data representations as well, which might not be structured. Those are unstructured in nature. So when we have to merge these two different kind of data sets and do data fusion problems, then GeoCroissant can be really helpful in terms of a graph representation for using your algorithms. Yeah, I skipped through it. We all are aware of how much Earth observation data we are expecting. These are all the missions which are going across NASA Earth fleet, and what better platform to talk about it with the ESIP team. We all know the amount of data set which is going to come in soon. NASA itself is expected to have around 35 terabytes of data set per day. So with that in mind, it becomes important to have proper way and planning in accessing the data set as well as metadata, because once the data set is in place, it's in cloud, then we will be advancing towards implementing the algorithms. And our algorithms are more scalable if the data access and is in a better shape. So with that, we came across with these needs, and that is how GeoCroissant came into the picture. Important things are how we can address bias coming across uh, the geospatial datasets. And these biases are important because once models are trained using these datasets, that we do not want our models or algorithms to learn the biases which are inherent in the dataset. So this is how we had some of the GeoCroissant objectives related to responsible AI and other things. And then the data quality and model training, also the reproducibility aspect. So how we can address reproducibility in terms of data access and data sharing. Uh, Again, I'll skip this slide. As I was discussing earlier, which is the Earth observation data sets are complex in nature because of different variety and different scale in which it is acquired and shared. These are some examples. Uh, This is how we propose to use GeoCroissant with the Geospatial Foundation model development, which is going on at our team in-house. So NASA's ODSI, previously known as Impact Project at MSFC, has been involved in a lot of foundation model development, such as Prithvi, weather for weather and climate, Earth observation, and the Helio one, which came recently. And that's how we were proposing GeoCroissant to be used in an end-to-end workflow. Now coming towards implementation, so GeoCroissant is, or Croissant to be specific, is based on schema.org attributes. And major work in GeoCroissant is happening where we are mapping the Croissant core schema towards schema.org attributes or properties. And in geospatial domain, we are also advancing interoperability with connecting it with the existing standards. Right now, we already have support for STAC, GeoDCAT, and OGC's training data markup language. And with this, what will happen if you have any of these existing file representation, you can create a GeoCroissant format representation out of it and then use it in your algorithms and workflow. So I see there are some questions. Is it okay if I take those towards the end?
Sure, it's one of those things which will get stuck if it's not clarified early, but if you don't mind going back to the previous slide.
Yeah, sure.
Sorry. Are the red ones you're saying are not available in current stack, and it's available in Croissant? Is that what you mean?
No, red ones are not available in schema.org, and
I
those
see.
are required. Yeah, because Croissant is based out of schema.org.
Okay.
So to do that mapping, if schema.org does not have some attributes or properties, then we can define those in Croissant core structure.
Got it. Yeah, that was the only question that it wasn't obvious.
Yeah, I'm definitely sure that some of these properties are there in Stack already. So that's what with the conversion or interoperability part we can achieve. Cool. I'll quickly do a segue here to define the RAI or responsible AI extension as well. So that is already in the web and we can have a look at it. It also defines some of the AI ready related responsible AI extensions, and those properties are defined in metadata. The simpler ones are citation and licensing, all the related information related to provenance and lineage. And that is where the next version or new development is going towards with OGC training data markup language as a supporting group as well. So in terms of GeoCroissant extension, we found out that when Croissant came and it got released, there were some questions related to its support for hierarchical data formats like NetCDF and HDF5 ZAR or virtual ZAR support, and also existing like interoperability with existing CNG data formats. Uh, this is how we are now moving towards GeoCroissant. And these slides, when I was presenting, it is coming from the early days of GeoCroissant. We have progressed a lot in development, and I'll showcase that with the specification as well. Some of the use cases are coming from different community members, including space weather datasets. So that's a use case which is developed by MIT, student who was working on STO or a Solar Data Observatory dataset representation as a GeoCroissant format. Interoperability with other formats I already talked about. Search and discovery is something which will be enabled by Hugging Face. So we are working with Hugging Face and Kaggle and OpenML as well to provide integration of geospatial attributes. Right now, they already have Croissant support, but with GeoCroissant support, possibly we will have more features available so that we can do the searching based on that. And geodata-centric AI approaches is being done as a part of IEEE GRSS project, where more data quality metrics and other things are being involved here. Hierarchical data formats representation is now a part of original core Croissant, so you can represent any of the NetCDF or HDFI file formats using Croissant or GeoCroissant. I'll skip this slide. This is more RAI specific. This example is important here. So HLS, we are all aware of Harmonized Landsat Sentinel dataset, and we came up with an example of how HLS GeoCroissant dataset would look like. And this is how the entire JSON LD, part of JSON LD looks like. The important part here is the dataset, which is stored as the original TIFF files, and the annotations which goes along with it, the masks. And in your workflow, when you are reading these dataset with PyTorch or TensorFlow, you can directly access the training data from these files. And we have some notebooks showing how to do it in GeoCroissant recipes as well, the notebook recipes. Nick, sorry to wait here. Can you confirm how much time do I have? Or is it
I would say like another 6 minutes or so. It's not super constrained here.
get? Thank you. So yeah, these were the questions we wanted GeoCroissant to address. We cannot address all of these as of now. Going forward, we have plans to look into data provenance and data lineage questions as well, along with some other partners. And how are we envisioning GeoCroissant, to be specific? So when we proposed, our focus was majorly on data fusion opportunities. So for example, if I want to query temperature at 2 meter level across globe or across a particular region, how can I just get the data on the fly for that region? And that is something which I don't have to follow the conventional route, downloading the entire data set, subsetting it, and then using it. Some of these things can also be done using cloud optimized and cloud native approaches, but how we can do it in an AI/ML workflow, that is what we wanted to address with GeoCroissant, and also enabling the relation between AI/ML community and geospatial community for all the support. So as I mentioned, since we are proposing GeoCroissant as a standard and we are expecting its launch by this year, maybe December or November, the version 1.0. So we are reaching out as much as we can for adoption. And as of now, as I mentioned, I had meetings during the IEEE GRSS in-GAS meetings with different representatives, and OGC is accepting it as a community standard. We are about to submit the charter nomination for that. ESA team has been interacting. We have been interacting with ESA team, Google Earth Engine team, Microsoft Planetary Computer team. So all of these are there. Some of those are on board with the support. Some of those are saying that we are majorly community-driven platform. So if we see interest, we will go ahead, and that makes a lot of sense. NASA is supporting it via the Veda project, and Veda will have GeoCroissant support in all the datasets which we have. Earth Data also made a release on its blog mentioning how GeoCroissant can be useful. This is how I got to know of the Council of Data Facilities, and if we are involved in any of the data repository support or any way where you see that Croissant or GeoCroissant can be used for metadata representation, we are happy to support. I would also mention that the UK CEDA portal, which is one of the largest provider for environmental data sets in UK, they are also working with us, and they have decided to go ahead with GeoCroissant for their metadata representation. So yeah, the specification is on its way. I'll share that in some time. And we have already integrated the GeoCroissant support in the MLCroissant Python package. So what that means is if you don't want to work on geospatial domain, it's all good. You can just work on MLCroissant Python package. But if you're interested in geo attributes, you can install it as pip install MLCroissant. It's very easy to do. And going forward, it will be also available for your GeoAI workflows. I think at this point, I'll go ahead and share the specification. So it's pretty big. I'll share the link for later preview. But as of now, I'll share what major use cases we are focusing on. So one is definitely how metadata related to geographical relevance can be stored. And this is something which came out when we were talking to Common Crawl Foundation. Common Crawl Foundation is a foundation which runs web crawls over the year across the internet. That's a very big data set which they generate after doing these crawls. And majority of the queries which they get are related to geographical relevance. So this is still in progress, and we are working out with them how these attributes can be defined in the data sets uh, based on GeoCroissant. Space weather datasets, I had a discussion about this in the presentation. It was coming out from the space weather datasets, which have very close relevance to Earth observation datasets in some sense. So how those can be defined into GeoCroissant. Interoperability with other standards. As of now, we are showing interoperability in our notebooks using for STAC, GeoDCAT, which is a geospatial extension of DCAT, and OGC's training data markup language. Then we also have some functionality related to OGC API records, which is a way of directly interacting your dataset metadata. So with this, what we are trying to do is we are hosting GeoCroissant files and then accessing those using GET or PUT requests, and you can directly access the metadata in such ways. On the semantic framework side, there is not much development, but we foresee that since GeoCroissant follows a graph representation, it would be easier to convert that into a turtle or RDF file format and doing querying on top of it. ML integration is there. Definitely, you can use any of the TensorFlow datasets support and directly run the examples for ML workflow. In the notebooks, I can show that we have one example of directly running a burn scar detection pipeline end-to-end using GeoCroissant support. And then we are also working on time series support as of now. With platform, if you have a Google Earth Engine asset, you can convert that into GeoCroissant file format directly. We have a notebook showing that as well. And all of these notebooks are available on Croissant GitHub repository. I can send those links as well so that we can have a look later.
Do you have a recommendation for file format when it comes to assets like Earth Engine? It's not a native format, right? There's not a TIFF file or a...
I had a long discussion about this with Simon when we were having this discussion, and ultimately we found out that it is easier to just convert assets to GeoCroissant file format as it is. I mean, not caring about the file formats in general, but just having the representation in the form of file or record sets. I don't know if I answered the question correctly,
Not
but this is
really.
exactly what, yeah.
Unfortunately, I think what I'm trying to understand is from a standards perspective, it seems to me that you have image format as one of the required standards. And I don't know if GeoCroissant has a validator similar to how STAC has a validator. I'm guessing it does. So if you're looking at a spec and if the spec requires format, can you leave it empty? That's what I'm trying to get to.
Yeah, so to be honest, you can leave that as it is as of now, but that is not an ideal approach. We would want to have some mandatory or similar to STAC specification, right? You need to define some mandatory attributes and you can keep some optional depending on what you're working on. So that is something which I remember having this discussion with Simon Ilyushenko, who is from GE team,
Yeah,
and they mentioned a similar case. They were saying that we don't see uh, actual need of converting Earth Engine internal metadata representation to any
got it.
other format which users would be requiring.
Okay, yeah, got
So
it. And they do everything in collection level anyway, so they're not doing it at
yeah,
item level. So it would be very interesting to see how that deviates from your version as well. So, anyways, continue. Sorry, I didn't mean to,
yeah, no, I'm done. So up to the questions. So thank you. And is that sum up, Priya? If I
Yep,
remember.
yep.
Oh, hey, I reached out to you as well over email, I remember.
Great.
Well, thanks for that. People have any questions or comments? We're happy to entertain them. Let's see. Rishu?
Yeah, hi, Rajat. Thanks for the
Hey.
presentation. So I've been following it quite a bit. When do you think this will be released, the spec itself? And will you be releasing it with actual examples? Because I know that you looked at I mean, in the initial few slides, there were different kinds of data sets like point clouds and all those things. Do you have specific implementations for those where it's very tied to a specific data type, for example? And I have a few other questions also, but maybe we can start with that part.
Great. Thanks, Vishu. So I'll start with first question. When are we planning to release? So from our side, we are ready to release. The MLCommons team, they are planning a Croissant 1.1 release as well. That is an extension of what they released last year. So once that happens, we will probably include GeoCroissant release in that as well. So that is why it gives us a lot of time as of now to keep on getting reviews for the specification and the implementation. And having said that, for the second question, which is what implementations we already have. So the recipes or notebooks which we have prepared, they show introduction to GeoCroissant. It is an end-to-end notebook where you can just get an introduction to GeoCroissant and how you can run a simple machine learning pipeline using that. And then we have for SIDA UK portal. So they have their own ways of representing data. It uses STAC internally, but it is a modified version of STAC which they use. So for that, we have one notebook which shows this example. We have one example showcasing how data cubes can be converted to GeoCroissant, how a ZAR file format can be used and converted to GeoCroissant representation, for which we use the NASA Power dataset. And then one notebook is if you have a Google Earth Engine asset, how you can convert to that, how you can convert that to a GeoCroissant specific file format. And similarly for GeoDCAT and STAC. So this is what we have. In the slide, I showed a lot of data sets. I don't have, as of now, examples for all of those, but we are assuming that more community partners will join in and they will develop some of these samples.
Yeah, maybe if you have those links available, if you just took a second to put those in the chat
Yeah, the
to
GitHub.
the GitHub and to, I guess, the spec, if you want to share that spec draft.
That would be useful. Yeah.
Well, while you're doing that, maybe one more question. I think if I heard correctly, like I know that MLCommons is an extension of schema.org. Sorry, the Croissant is an extension of schema.org. You mentioned support. What does support for STAC mean? Like STAC spec is going to be expanded to support Croissant and GeoCroissant?
I cannot answer that as of now. I mean, if so, we are clear that we don't want to have that 15 standard where it says that, okay, we are standardizing 14 other standards. I am well aware of that meme. But it is more of like if we can integrate, if we have something from which allows us to go from GeoCroissant to STAC or to GeoDCAT or any of these things, and something and provides us something which is very useful for AI/ML workflows, then it is that is our major objective. Because this question came up when we were talking with OGC's training data markup language, and they were like, "Oh, we are a step forward in all these. We have provenance and lineage already implemented. So why don't we directly call it as OGC TDML and not call it as GeoCroissant?" and integrate all of these. So, and in that front, our major point was that we are more towards using Croissant and building those functionalities of AI/ML workflows into geospatial domain. If that happens to be an extension of an existing standard, that is, it's okay. We don't have any issues with that.
Okay, I guess I mean, we don't have any particular fixed preference. We support both schema.org and STAC, but I guess the question is like, can we do both if it's like a spec and then you're like putting in specifications for both at one point? Okay, maybe if I
Yeah,
see
I think
that a little
correct.
more, like, once I see the spec, we can ask some questions on that.
I think it's similar to the question I had in terms of like if there is already an established format like Stack right out there, I can see that from a schema evolution, like schema.org evolution to adding additional metadata, you're, basically enriching what schema.org already had. But towards the very beginning, you said the goal of this is not findability, even though I think findability is one of your core objectives in that, when you were showing it. So is your goal findability? Because it seems to me that adding those additional attributes or metadata is going to make it better indexed with, Google dataset search, for example, that
Yeah.
will enhance basically findability. So are you solving for findability then, even though you started with saying it's not for findability? And then the second question that I have is from an ML perspective, right? Just because a dataset exists somewhere and you have the metadata for it, does it mean that it's ML ready? Because for example, maybe the image isn't tiled in the same way in the chipsets that the specific model requires, because it can only do 5 by 12 512 size chipsets, and it requires to do a parsing of all these different subfolders and attributes, and there is a derivative in there somewhere. So can you talk to us a little bit about like what is like ML parsable, ML ready, and findability? Like what are you solving for?
Okay, good question. I'll answer the second one first. So for sure, ML ready data set does not mean that we have labels and annotations and those can be used as of now directly. The metadata will involve a lot of other things. So the responsible AI principles, which the AI/ML community is focusing a lot on, they have uh, like functionality such as the biases which are associated with these data sets, or what is the provenance of the data set which is coming in. So in ML-ready ecosystem, a lot of things. So let's take an example of the satellite embedding data set, right? It is a synthetic data set because it is coming from a model which uses the raw input data and creates something which is a lower dimensional representation. And that could be useful for some of the use cases such as change detection or anything. Can we call that as a data set, or what is the provenance of that data set which is coming in? So these all things need to go in the metadata which are there of that data set. And when we started working on Croissant and GeoCroissant, we found out that the data set cards or data documentation, which are which are considered as the standards in this domain, were missing these things. So that is what we were targeting. And coming to the findability part, of course, we're not solving that for GeoAI use cases because Stack does that, and uh, we need to do that if we have to abide by the principles of FAIR principles or all the extended FAIR principles which are there. But with respect to Google dataset search, that was the original idea, like to get it indexed in the dataset hosting domains, which are usually used by the AML communities. So be it Dataverse or be it uh, Kaggle or Hugging Face and all these things.
Got it. So the whole objective of this is to make data AI ML findable, not ML ready, right?
Yeah,
If I understand this correctly, because I think that's one of those things that people misunderstand quite a bit, that the source data may not be like in a format, may not be ready to be consumed, may not be plug and play, for a lack of a
yeah,
better word, right? In the same way in which people are thinking that, hey, this data is ML ready. Lots of air quotes on that one. So I just want to like create that distinction. So GeoCroissant is going to
yeah.
make it ML findable, and then there's something else that people have to do in between to then get to the ML ready part. Of course, it could be ML ready to begin with, but not all. Just because something has a GeoCroissant metadata, it doesn't mean that it's ML ready, right? Okay.
Yeah,
Got it.
for sure. That's a very well way of describing it. Thank you. Because and to add on to that, there is one group from Paris, CoData. They are also looking into how these GeoCroissant data sets. I mean, they are working on Croissant, but they are also involved in GeoCroissant effort. How these can be hosted as an MCP endpoint, so that tomorrow, if you have to access those using application layer, you can directly like access those data sets.
That
So
sounds
that
great.
brings on this part. Yeah,
Yeah, I mean it'll be the same issue as STAC. If your links die, then
correct,
you would have to crawl
correct.
everything.
Yeah.
But yeah.
Anybody else
Uh,
have questions, comments?
You mentioned that you had notebooks. Is this in the doc also?
No, Vishu, notebooks are not in the doc, but I shared a link to PR that I need to just merge it. It's approved on Croissant repository, and those will give all the notebooks. There is a Python package documentation which we are working on. So those are different from notebook. You can directly use the converters which are there in that package. So we'll work on the documentation soon.
Thanks.
How many levels are you going when you're looking at provenance? I'm curious about the derivative because you're obviously going to have derivative data sets as you were talking about, right? Like, for example, Prithvi or with the embeddings and Alpha Earth, for example, with its embeddings, right? There's different licenses for all the data sets that went into creating Prithvi as well as for this one. So how are you going to have one single representative license for the derivative? And how many layers up are you going to go? Like, what is the parent in that case, right?
Uh, I'll tell that straight away that provenance and lineage related to GeoAI, I think, like in GeoCroissant, we haven't started on that front yet. That is something which we are planning to go after the launch happens. In the responsible AI team, which is looking into Croissant's provenance effort, they are working with the stage bio networks and health related domain, and they have provenance as an important aspect as well. So they are right now looking at the data level provenance, data set and data level. So those are two hierarchies which they are looking into. They are not going into a sample level provenance as of now, how a particular data point will change over the time. I think that will be an even difficult problem for us because to keep a track of a single pixel or something over the course of changing it from raw data to synthetic data, it will be really very difficult. I don't have any plan as of now. Maybe what the media domain is using. I think I'm forgetting the term, which is CDIF or something. We can look into that, but as of now, I don't have any answer there. Sorry, Sam. Yeah, Ethan, please go ahead.
Yeah, thanks for the talk. I joined a little late, so I may have missed some things. But in terms of the ML ready versus ML findable, what makes it ML findable rather than just findable? Is it the provenance? I mean, I think you were talking about it, and I just kind of didn't quite catch it when that conversation happened. So is it the provenance and what other than the provenance is it that is missing from existing like STAC and whatnot?
Provenance and lineage is something which we usually talk about. So provenance is what was the source data when it was hosted, and then how it has transformed over the cycles of be it algorithm or pre-processing. And then, so let's say if I took a raw data and if I generate embeddings out of it or generate any different product out of it, that can be considered as a new data set altogether for a different machine learning workflow. So if something or some underrepresented results are shown in the final output, who is responsible for the original data set or the entire product? So those things are answered with provenance, and lineage is something similar, which is like even if there are branching happening in the data set, how those data sets are actually connected to the raw or original source of data set. In our case, sorry, I'll just finish off with the last statement. In AI/ML ecosystem, this is easier to do because they usually follow an approach of a training data set and then a label which is associated with that training data. So you know who has done the labeling and you can note all those information. But in geospatial use cases, we usually do not have all the problems which have labels differently from the training data. We kind of derive sometimes the labels from the training data itself. So for example, working on compression or reconstruction problems, the data set which is still coming from the actual data set. And yeah, I'll also let Sam answer this question about the ML
I was
findability.
just typing that it might also be simply to the fact that, Ethan, that one of the places that people go to, right, central repos that people will go to is the Google Dataset search, right, or Data Commons or something like that, and they are encoding the metadata in specific formats. So they started with schema.org. They didn't use STAC for doing any of this, and they did schema.org because schema.org was more generalized across domains rather than STAC, which is specialized across geospatial, right? So it seems to me that, and this is a guess, this is a wild guess, because if you look at Google Dataset Search, it doesn't support STAC. At least that doesn't say anywhere that it supports STAC natively. So my guess is it might be simply related to the fact that, hey, STAC has a lot of these things. Yes, it won't have provenance in the same way, because if you go into derivative data set, the same issues that we were talking about a few minutes ago is going to happen, where how many levels up are you going to go in terms of parent data set? How, like, if you go into the whole like collection 1, tier 1, collection 2, tier 2, everything breaks down, right? Because you're going to have these subdivisions between the data sets. Then you have version control of data sets. If the data is re-released with different versioning, is that represented in STAC versus GeoCroissant? So I think it's like nuanced choices that data aggregators used, and which is why a specific metadata standard serves that. So it's ML findable because ML is looking in those places. But I don't think that you can't, like, there's nothing that is stopping someone from connecting STAC to like AI and asking questions. And in fact, we do this for Community Catalog right now.
Yeah, and so I thank you. I think that all makes good sense. And one quick question, well, two actually. It seems like for me, lineage and provenance sound very similar, and so I'm wondering what the difference is there. And my other question is, are you going to be at the OGC meeting next week in Boulder? Or is somebody involved going to be there?
These questions are for me.
Well,
Yeah.
sure, yes, but for whoever.
Okay. I am not planning to be in Boulder for ODC meeting. I'll be attending the GeoAI technical committee call. So the GeoAI standards working group, they are supporting the adoption of GeoCroissant as a community standard. So we'll be having some discussion on that. I presented in the last month's technical committee, and that is where the things came out. Sorry, Ethan, I keep forgetting the first question. What was the first
Oh,
question?
it was the difference between provenance and lineage and how they interact or compare.
Yeah, I think I have more clarity on provenance side as we discussed. Lineage, even I am not very well aware of, but it has something to use with the data use and data retention policies. So this came out in the discussion when we were talking to Sage team. They are the health experts. They have the entire repository of bio related data sets. And in their use case, they want to flag the identities associated with the data sets a lot of times when we are using in these ML models. So they want to use some attributes which will make this available so that even if the identity related to a particular data sample is flagged, then also the provenance information should not be missed. So that is where the lineage came into discussion. I can forward the link to that specification document as well, which they are working on, if that helps. I am not directly involved in that, but I am happy to invite any of you in that meeting. And same goes for GeoCroissant meeting as well.
Thanks. Yeah.
Thanks for the question.
Rajat, is the GeoCroissant meeting something that's happening regularly? Like, is this like an open meeting that anyone can just go and listen in and?
Yeah, it is open meeting. We meet bi-weekly, and then one on a US time zone compliant time and one in a Europe time zone.
Okay.
I can add the interested person. It's a smaller community as of now, and majority
Small is
of the
good.
work, yeah. So yeah, happy to share invite with all of you.
Thanks.
Yeah, that would be great. Thank you.
And yeah, thank you very much for all the questions. It was indeed a great discussion.
All right. Well,
Thanks, Karen.
if we don't have any more questions, we can finish up a little early here. And anybody else, something to add?
Nick, this is my first this meeting. Actually, I just got to know about this from a colleague of mine also.
Mhm.
Is this like a bi-weekly, once a month, the Council of Data Facilities meeting? Can you tell us a little bit more about?
It's a once a month.
Okay.
And we're ESIP cluster that came out of EarthCube, a group of data facilities that just trying to share information and possibly influence data repository environment and landscape. So
Okay, got it. Yeah, I bet a lot of you are at the Living Data Symposium right now happening, right? No, maybe not.
not myself.
Okay.
There's a lot of things going on.
Yeah, no, I totally understand. I was just curious because I was like, this is fascinating and it was really fun. And if there's a calendar somewhere that we can go and see like which talks
Yeah,
we.
there's an ESIP calendar, all
Oh,
the different groups in ESIP, and
would
we're
you
one of
mind
those.
dropping the link?
Sure.
That would be great. Thank you.
Let's see here.
Probably also worth getting your name on the mailing list and or the Slack channel. That's where we usually announce topics. I'm not quite clear on when and how they get into the calendar. Like if we always have the topic in the calendar, but we usually email about it.
Awesome.
Yeah.
So we can just sign up using the calendar or just put our name and email address and one of you can help add.
Ah,
Yeah, let's see.
do you know, Nick, how we add
Yeah,
people to the
I
mailing
think
list?
there's a link in the calendar. Let me just
Sorry, I know this is nothing to do with what Raj just presented, but I was just curious. This was
No,
fun,
it's all
so
good.
yeah.
Yeah, this is, I wanted to join the mailing list as well. So
Excellent.
thanks.
here's this information. So I think if you go to this list link, you can sign up,
Got it. Okay.
and that'll get you announcements for the channel, upcoming events, that sort of thing. You can also post if you have information that you'd like to post, you can also post.
No, this is great. Didn't know about the ESIP Slack. It's gonna be fun.
Oh yeah, you've got a lot waiting for you.